Can you see my screen?
We can.
I hear a feedback from my voice. Okay.
We do not. We do not. So
okay. I hope I don't hear it anymore. Okay. Awesome. Thank you. Thank you for inviting me. It's been a pleasure to participate to this. Lots of interesting talks. I'm going to talk about understanding the impact of climate change on the greenhouse gas emission from the Arctic. But before I do this, I want to introduce my lab and all the people that made this work possible. All my students, Francia Macal, the technician, Joy, Marco, the other graduate student, Kevin, Christine, Danielle, and some PhD student, Kyle and Josh, that just graduated and now are postdoc and research scientists at Woods Hole and in University of Freiburg, Germany. And of course, I need to thank Walter Rochelle, which established this research more than 40 years ago. We wouldn't be talking about any of these results if it wasn't for him. And Kim Peterson, which is a honorary member in our team. And this is not exhaustive of all the people that helped collecting this data, keep these instruments alive, and be able to make sense of what they mean. So what are we doing? What our research group is doing? Well, what are we doing? We are measuring the breathing of the tundra. This ugly eddy covariance tower, what they're really doing are measuring the net between the CO2 that is uptaken by the vegetation and the CO2 that is emitted by respiration, both vegetation and soil, and trying to figure out how climate change is affecting the CO2 emission. But CO2, it's only one of the greenhouse gases that are being released or uptaken by tundra vegetation. In recent years, we start focusing also on other greenhouse gas emission, including methane. What we discover when we establish this new instruments a few years ago, now almost a decade ago, we actually found that the cold season emission were a major part of the methane budget from these Arctic ecosystems. We measure a consistent loss across all our 5 sites. This was published in PNAS in 2016, and we were fortunate to collaborate and also be involved in the NASA CARV that flew an airplane and measured the entire node slope emission, and then we compared the emission from the airplane to our eddy covariance fluxes, and we found a consistent loss well into the fall with both these measurements, which really speaks to the scale of the emission. So it's not only what's measuring the point of the towers, but it's something that is consistent across the entire snow slope of Alaska. This was, we were really fortunate to have some substantial media attention. The Washington Post interviewed us. It's nice to see that some of your science can potentially make an impact on society, and then a variety of other research network published some articles about this work. So where did we go from there? One of our graduate students now is, as I mentioned, Kyle Arndt, is currently a senior scientist at Woods Hole, so not bad as a career. So we are happy for him. So basically what he did is extend the measurement to a longer time period, and they looked also at a potential change in the emission over this time. So what he found by using nearly a decade of data, that the tundra was, the soil in the tundra was freezing later. So what you see on the left panel is the zero curtain end date. The zero curtain is a period in which the soil is still unfrozen, and if the soil freezes later, there is more time for the tundra to emit emit a more substantial amount of methane. He also tried to see if this later soil freezing was affecting the atmospheric signal. And what you see on the right panel are the terrestrial methane enhancement. These were some of the data that Brian mentioned, actually. Thanks, Brian, for collecting this data. Com Sweeney helped us with this analysis. The terrestrial enhancement is when the methane is coming from the terrestrial sector and how much is above a background level. And what he found with the later soil freezing, there was actually a substantially higher methane enhancement. So more methane in the atmosphere, which was related to more methane emission from the period in which the soil is unfrozen, which was a really nice time series analysis. So also this paper was featured in EOS, so we were happy that we got some attention and some interest. Now, this is another work, more recent work, switching gears, looking more at what the greening, how the greening is affecting the carbon balance. Everybody is talking about how the Arctic is greening. That's a good thing. Vegetation is happier because it's getting warmer. So I basically started working on this paper about 5 years ago. It took me 5 years to get this done. It was something. Initially, I collected data only from Alaska and only from my towers. Then I started reaching out to other scientists that were running towers in other parts of the Arctic. The reason why is because I was trying to relate the earlier snow melt, so earlier activation of the ecosystem, the tundra getting greener, with more carbon uptake. And everything I was doing, any analysis I was doing, nothing was significant. I said, how can that be? And I thought maybe I don't have enough points, so let's get more points. I kept collecting points and standardize them, calculating anomalies, doing all sorts of analysis. Nothing was significant. So I was not seeing a larger carbon uptake with an earlier snow melt. And it wasn't until a reviewer of this paper finally suggested, why don't you look at different time of the season, that I find, okay, that's the reason. What you're looking at is the anomalies of snow melt versus anomalies on net carbon uptake. More negative anomalies of NE with earlier snow melt means more carbon uptake. So what I was seeing that in early and peak season, there was more carbon uptake with an earlier snow melt, but in the late season, there was more carbon loss. The sign is switch in GPP. GPP is the plant productivity. So more positive GPP means more productivity, more negative anomalies in the GPP means less plant productivity. So both of these fluxes were suggesting the same thing. It's a little bit, when you wake up earlier in the morning, you are tired earlier in the evening. So when you're trying to model the entire season, you don't see a benefit to the net carbon uptake of the entire ecosystem, because the earlier uptake in the season, in early season and peak season, is lost in late season. So also this work was also picked up by the media. They were very interested in this research result. It was nice to see. And I think it's because they published a paper on published an article on our work and putting this cute little Arctic fox in the front page. I had to admit, I tried to use these cute furry animals to increase the recruitment, because the Eddy Tower are pretty ugly and people are pretty bored when they look at them. So that was, let's say, successful for this. Now, just to address some of the research gaps that we are trying to fill with our research, Understanding the origin of the methane during the cold period. This is something we are still trying to do. It turned out to be more difficult than we expected. It's important to do because we are trying to understand what's controlling these emissions and how they might change with climate change. Also, we just were awarded NSF EON, which was great. It was really great to maintain our instruments and keep our tower running. We are trying to reconstruct the long-term temporal changes in the greenhouse gas balance. And more recently, I just got the award notice a couple of days ago. We were just awarded the NSF ANS to understand the role of the permafrost degradation on the full greenhouse gas balance, looking at other greenhouse gases other than CO2 and methane, namely N2O, and see if we can see a role if we can see if N2O emissions are important related to some permafrost degradation. And for this, one of the challenges and the research gaps is trying to understand the role of different microtopographic features and how degradation is affecting a different microtopographic feature across a very heterogeneous landscape, and also reaching areas that are really hard to reach otherwise. For this, we were awarded support by NSF with an helicopter campaign who started in summer 2023 and then continue also in summer 2024. So this is hopefully next summer we will be able to answer some of these research questions. And for this, just an advertisement, we are hiring. We have an open position for a postdoc, a field research technician. The postdoc is already, the details are on this link, which is in San Diego State. And the last question was, what can we do for supporting a sustainable, diverse, inclusive space for Arctic research, where there were a lot of, there are a lot of different angles, a lot of different ways to answer this question. I personally, as a woman in science with a small child, I can tell you that anything that can be done to support women to travel to the field and be able to bring their kids when they are doing their field work are extremely important. We had the hats in the past. Now, I mean, the Hook Picnics is a fantastic facilities if you don't have children, but if you have children, it's very difficult to bring your kids. So anything, I know it's housing, it's very difficult and very limited, but something that can be done to help women in science. I think it's trying to have, like trying to negotiate the opportunity to have a more flexible housing accommodation for families. And now it's the time to thank all the people that made this possible. These are not exhaustive of all the people that supported all our research across the last decades, but I figure I'm gonna start somewhere. So USC Science and all the team of people and all the technical support that kept this tower running, and who's paying the bills. NSF, of course, was huge supporter of this work, but also the NASA CARV and NASA BOV program and NOAA, Cesar. There are a lot of other funding. This is absolutely not exhaustive, but I needed to at least show the major funders for this work. I don't know if there is any time for questions, but I wanted to show this slide.
That's a cool slide. Thank you so much for your presentation.